Hello everyone, so today we are continuing a video on applied calculus. In the first part of the video we were looking at finding some functions, the cost function, the revenue function, the domain of the revenue function, and part D here, that's what we finished off with, which was the profit function. And then we had three more parts here, which were the marginal cost, the marginal revenue, the marginal profit, and the maximum revenue. Okay, so that's what we'll do today. So parts E, F, and G here, and that's a horrible F here, my apologies. Let me make that a little better. And a horrible G. Parts E, F, G are basically taking derivatives of our function. So let's go to our function. So find the marginal cost. All you're going to do is you're going to take the derivative of this function, and yeah, derivative 300 is 0, it's a constant. Derivative of 0.51x is just 0.51. And essentially the marginal cost tells you how much more cost you'd have by producing one more unit after producing X number of units. That's what the marginal cost is interpreted as. Okay, so for the marginal revenue now, I'm going to go ahead and take the derivative of that as well. So this would be 5 minus 0.002x. Okay, and what the marginal revenue tells you is the amount of money you should expect in an increase in revenue or decrease if you made one more unit after X units were made. Just to go into that a little further, if you produce, let's say, 30 items of something, if you plugged in R prime of 30 into your derivative here for R, the marginal revenue, this tells you how much revenue is gained or lost from making 31 items, okay, whatever you're producing, that's what that means. So similarly for the marginal profit here, P prime, that's going to be 4.49 minus 0.002x, and same thing. If you produce X number of units, and you plug that number into, so again, 30 or whatever units of something, plug it into this function that tells you how much profit you expect to make or gain from making 30 or 31 units. Okay. And then finally the maximum revenue. So for the maximum revenue, this kind of goes back to what we learned with applied minimums and maximums. And I understand some people might not have gotten to that yet. And you can always check when you get to that, you can always check back on this if you want to make sure you have the right idea, which is as follows. You're going to take the revenue and set it equal to 0, because the idea is the revenue function has this going on, so it can have a min or a max. Typically your revenue functions, you're interested in kind of like this part right here. And yeah, so we're going to take the revenue, we're going to set it equal to the derivative of the revenue, set it equal to 0, so 5 minus 0.002x. And if you set this equal to 0, you will get 5 divided by 0.002. That's equal to x. And that would come up to be about 2,500 here. Okay. So it's 2,500 units. That would give you the maximum revenue. Now this is not the maximum revenue yet. That tells you how many units you would produce to get the maximum revenue. Okay, so how do I actually get the maximum revenue? Well, we were told earlier when we were doing part 1 of this video that the revenue here was equal to 5x minus 0.001 x squared. So what you would do is you would just plug in 2,500 into here and see what you get out of it. 2,500 squared, and we're interested in answering. Right, so I hope this helps. Thank you for your time.